G'day Year 11, welcome back to Mathematics. Here is your revision questions to start today's lesson. From the 2015 and 2016 HSC papers, these were the first questions. I want you to pause the video and figure out your answers for both of them. Alright, so for the first one, we're rounding to two significant figures. So if we go left to right, 1, 2, stopping at the 0, the 8 rounds us up to a 1, so it must be B, 210. Okay, these two are both 5 significant figures. This one is 3, so it must be this one. Okay, for the next one, writing this in scientific notation, aka standard form, corrected to sig figs. So straight away we can rule out options A and option C because they are both 1, 2, 3 significant figures. So we just got to figure out if it's 1.6 times 10 to the 5 or times 10 to the 6. So if we look at our whole number, if we see how many spots this decimal place is going to jump like we did last time, 1, 2, 3, 4, 5, 6. So it must be option D. So there are your answers. B for the first one and D for the second one. Okay, so today's lesson is on energy consumption. So this is something that you would not have seen in years 9 or 10 or before. This is a brand new concept. It is kind of confusing at first, so you will need to pay close attention. Okay, so to start things off, let's look at our units for power and energy. Okay, so in this course, or in any course really, power is measured in watts. Okay, this is named after, I believe his name is James Watt, who sort of figured all this stuff out. This is our base unit for power. Okay, so power measured in watts. Now, energy consumption is your power being used over a period of time. Okay, this is measured in kilowatt hours. All right, so a kilowatt is obviously 1,000 watts, just like a kilometer is 1,000 meters. H for hours, so if you take how much power you're using multiplied by how long you're using it for, gives you your energy consumption. Okay, so kind of like power is what you need to sprint, but if you want to run over a long time, you need energy because that's your power multiplied by your time. Okay, another simple example is if you have an appliance that is using 1 kilowatt of power to run, you're running it for 1 hour, you are going to use 1 kilowatt hour of energy. Okay, so it's not kilowatts per hour, it's kilowatts for an hour, essentially, okay? So if you were using a 10 kilowatt appliance for 2 hours, you would have 20 kilowatt hours. Okay, it's just multiplying the kilowatts of your appliance or whatever the thing we're looking at is, multiplied by the number of hours, and we get kilowatt hours. Okay, so that's the logic today. We're going to be finding kilowatts of appliances, multiplying with them with how long they're running for, and then applying this to some sort of energy rate. Okay, usually in Australia at the moment, a kilowatt hour of energy is going to cost you about 25 cents, roughly, so $0.25. All right, so moving on. You may have seen these labels on your appliances around your house if they're relatively new. I know my fridge has one of these on them. So this is your energy rating label. Usually more stars means it's better for the environment. It's using less energy, which is going to cost you less money, which is good. Now, the important part that I always look at is this thing right here. This is the number of kilowatt hours per year. Okay, so if this was on my fridge, this fridge would use 380 kilowatt hours of energy over a whole year. And because I just said that a kilowatt of power costs you about 25 cents, $0.25, if you divide that by 4, so you find a quarter of this, you will find how much money it will cost you. Okay, so if you know that, you can just look at this label and you can use basic mathematics to figure out very quickly how much your appliance is going to cost you per year, or if you wanted to go per month. Okay? All right, so an example to start us off. We have Anakin has a 6,500 W for watt lightsaber. If you use this weapon for 4 hours a day, how much energy in kilowatt hours will he use in a week? Okay. So the important part of this question is what we're trying to find, which is the number of kilowatt hours. Okay. So like we said in our notes, we need to find the kilowatts of our appliance, which in this case is the lightsaber, multiply it with how many hours we're using it for, and we will get the kilowatt hours of the energy consumption. Okay, so we know that 1,000 watts is 1 kilowatt. Okay, hopefully that's obvious. So I want you to think, how many kilowatts would our 6,500 watt lightsaber be using? Okay, so going from watts to kilowatts, we are dividing by 1,000. So if we divide this by 1,000, we get 6.5. Okay, so our lightsaber is using 6.5 kilowatts of power. We're using this for 4 hours a day for a week, so 7 days. So we're doing 4 hours a day times 7 to get 28 hours. Okay, here is our power. Here is how long we are using it for. So if we multiply these two together, we get our kilowatt hours. Okay, kilowatts times hours. That's the concept. Okay, so we put this through a calculator and we get an answer of 182 kilowatt hours. That is our energy consumption for the week for our lightsaber. Okay, final answer. All right, we can do another one now. We have the Palpatine family have a 70 watt television, which is pretty energy efficient. Most of them use a bit more than that these days. If the TV is used 2 hours every day and the family is charged power at a rate of 23 cents, $0.23 per kilowatt hour, what will the yearly cost of running this TV be? All right, so let's do it. So first thing we need to find is our kilowatts. Then we need to find our hours, to find our kilowatt hours, to find our price. Okay? So once again, if 1,000 watts is 1 kilowatt, then we have to think, what would 70 watts be in kilowatts? So in the last example, we divided by 1,000. We're going to do the same thing here. We're going to do 70 divided by 1,000 to get 0.07 kilowatt hours, okay? Because we're going from watts to kilowatts, dividing by 1,000. Now that's our kilowatt. Now we need our hours, all right? So if we're using it for 2 hours a day, 2 hours every day, so if we do 0.07 kilowatts multiplied with 2 hours, we will get 0.14 kilowatt hours. Okay, kilowatts times hours is kilowatt hours. So this is the energy consumption every day, okay, because the TV uses this much. We're using the TV for 2 hours, so here is our energy, okay. If we've read the question carefully, we don't want the daily running costs, we want the yearly running costs. So how are we going to go from daily running costs to yearly running costs? Any suggestions? Yes, Ruby? Correct. We're going to multiply by 365. Well done. So if we take our daily energy consumption, multiply by number of days in a year, we get our yearly energy consumption. So we're almost there. Now, if we're going to use 51.1 kilowatt hours over the year, and for every kilowatt hour, we have to pay 23 cents, well, we just need to multiply this number by 0.23, and we'll get how much money this is going to cost us. So that's our final step. We just need to do 51.1 kilowatt hours multiplied by 23 cents, and we get $11.753, which we'll just round to 75. And there is your answer, which is very, very cheap because, like I said, this is a pretty energy efficient television. The newer big flat screens use a bit more than 70 watts, so be aware. All right, so that is a typical examination style question. You've got to know how to find your energy consumption and then apply your cost. Okay, that'd be a good 2-mark question. All right, if that is making sense to you, if you followed that, you may be ready for a challenge question. This one is from the 2015 HSC paper. It's labeled as a Band 5 question. Now, in the HSC, a Band 5 means a mark from 80 to 89. So what they're saying is that students who are getting marks in the 80s were typically able to do a question like this. So it's a very hard question relative to most of the paper. We have the energy consumption of a computer in standby mode, which means that like it's off, but it's not really off, you know what I mean, is 21 watts. The cost of electricity is 31 cents per kilowatt hour, a bit more expensive than our last example. A school computer room has 20 computers. How much will the school save by switching off all 20 computers during 11 weeks of school holidays? So what we're trying to do with this question is figure out how much power we are going to use by running these 20 computers for 11 weeks. We're going to multiply that by 31 cents and figure out how much money it would cost us to have them running. And then if we turn the computers off, we'll save that amount of money. Okay, so the goal of this question is find how much money it's going to cost you to run these computers, and we're going to save that amount of money, okay? So first things first, if our computer is using 21 watts, we need kilowatts. So I want you to think how we get from 21 watts to kilowatts. Just like the last two examples, we are dividing by 1,000, 0.021. Now that is just one computer. If you've read carefully, this school has 20 computers, which means we're not going to use 0.021 kilowatts. We're going to use 20 times that. We're going to use 0.42 kilowatts. Okay? So this is how much power is being used to run our lab. And now how long are we going to be running these computers for? 11 weeks of school holidays. We need to figure out how many hours there are in 11 weeks. Okay, so think about how you would do that. So the number of hours in 11 weeks would look like this, okay? 11 weeks, every week is obviously 7 days, so that's 77 days. Every day is 24 hours, so we do 77 multiplied with 24, and we get 1848 hours. Cool. So here is our total power. Here is our total hours. If we multiply the two together, we get our energy. So we'll do 0.42 kilowatts multiplied with 1848 hours, and we get 0.16 kilowatt hours. Okay, cool. We aren't even done yet. We haven't even got our 2 marks yet, because that is how much power we are going to use. That's how much power we're going to save by turning these guys off. So now if we want to find out how much money we're going to save, we've got to multiply our number of kilowatt hours with our cost, which is 31 cents per kilowatt hour. Okay, so very last step, do 77616 multiplied with 31 cents, and we get $240 and change, which we're going to round to 61 cents. And there is your final answer. All right, if you managed to get that by yourself, well done. If you managed to follow along with me and make sense of it, well done as well. All right, now is the time for you guys to try some by yourself and see how you go. Here are some questions in exercise 4E for you to rip into. And that should do it for today. Thank you very much for watching. I hope you learned something. I'll see you next time.